All right, we're doing 2-4, solving equations with variables on both sides. We're getting to the point where these things start to look nasty. But if you just treat it like little tiny steps, it's really not bad. So just kind of keep plugging along and enjoy it. All right, so kind of some hints I'm going to start out with. This is what I like to do. So first of all, move all the variables to one side. So move all the variables to one side of the equation, or one side of the equals, as a first step. Then you just solve it like normal. Now, which way you go, which side doesn't matter, but sometimes one side will be easier than the other. I usually move the smaller one. So if you have like a certain number of x's on one side, certain number of x's on the other, I move the smaller number of x's. And I do that because it typically avoids negative numbers. I don't hate negative numbers, but I prefer positive. So if we can keep it positive, just kind of less to go wrong, really. All right, so this first one, not too beefy of one to begin with. 8x equals 3x minus 40. Well, I'm going to take and move that 3x. So if we take and do that, so it's a positive 3x. It's maybe tempting because of this minus 40 to go and add 3x to both sides, but that's not going to work. That minus sign goes with my 40. The plus sign there is with my 3x. So I have to start by subtracting 3x from both sides. All right, and then when we do that, I get a 5x on the left equals, my 3x is gone. It's tempting maybe to just write the 40, but you have to remember, we just got rid of that 3x. We still have that minus 40 or a negative 40 hanging out over there. All right, last step. We want to get x by itself. What was done to it? It was multiplied by 5. So you have to do the inverse of multiplying by 5. We divide by 5. And when we do that, the 5's drop out. You're just left with x equals negative 8. And we could go and take that negative 8 and put it up here for both x values, and we should find that it is indeed equal. All right, we jump down here. And hopefully your typo is fixed, but I'm looking at this here, and this actually isn't solvable the way it is. That needs to be a 6, not a B. So I'm going to make that a 6. Hopefully you don't have to deal with that issue. And we got A's kind of all over the place in there. So I'm going to start by just taking this left side. I have a positive 3 of them right there. And I have a minus A. So that's actually going to be a 2A over here on this side. And if your brain doesn't do that, you could say, well, minus what? Well, it's minus 1A. That's just a 1A there. We don't have to write in the 1. But that gives me that many A's. And then I have this 6, so a minus 6 still. Because remember, you kind of look at the number or the variable and the sign that's in front of it. So minus 6. Then on this other side, I'm going to take and do a little bit of simplifying. We can't like subtract 3a from both sides because that's kind of in the middle of this big multiplication problem here with distributive. But we could get rid of that. We could say, all right, so I have my 4. I'm just going to copy that down. But then it's this negative 2 times the stuff in the parentheses. I'm going to distribute that minus 2 or that negative 2. So negative 2 times 3a gives me a minus 6a. And negative 2 times a negative 5 gives me a plus 10 or a positive 10. So we're to there. And once I'm there, now we can take and kind of move around some a's again. I'm going to move the 6a. So I have this positive 4 right there. I have this minus 6a, and I have a plus 10 or a positive 10. And I was saying move the smaller one, but this one here is negative. So it's just kind of like begging me to move it to the other side. So since it's a minus 6a, I'm going to add 6a to both sides. And doing so gives me a 8a minus 6 equals, I'm going to take and cram these two numbers together. So I have a plus 4 and a plus 10, or a positive 4 and a positive 10. So that's going to give me a 14. All right, once we're there, we're to a pretty normal looking one. And said do order of operations backwards whenever you're solving for a variable. So now we're kind of working backwards to find a, so that's where we start doing this. And sometimes you maybe instead of this parentheses, you'll see that as like a grouping symbol. But all right, I digress. So first, addition, subtraction. We had this minus 6. We have to do the inverse of subtracting 6, which is adding. So that gives us a 20 over here on the right. And the 6's are just gone, so we have an 8a equals 20. All right, they multiplied a by 8, so we need to divide by 8, kind of the inverse of multiplication. And doing that, we get a equals 2.5. And again, you should be able to take that 2.5 and plug it in for all the a values up here in this original bad boy, and you should find that it's equal. All right, we're plugging right along. I'll slowly move that thing up. And the next page, we're looking at special cases. And I'll actually go and fill in kind of this a later. I'm going to start with the example. And let's jump to here. Now I'm going to skip my little line of writing there, and we're just going to dive in and see what happens. So when I have this here, all right, I have x in 3 different spots. I'm going to take this right-hand side and simplify that first. So I have a 5x right here, and I have a minus 2x. So that's going to give me a 3x total. And that kind of takes care of these two, but I still have this plus 2. All right, so the right side is 3x plus 2. The left side is a 3x plus 2. So it's really the same exact thing. Well, if we'd go through and solve this, yeah, might as well. I guess you can know you're in this special case if you find the exact same thing. But if we solve this, I'm just going to subtract 3x from both sides to kind of take and move this to the other side. But when I do that, all my x's drop out, and I just get a positive 2 equals a positive 2. So when we do that, if the x's drop out, x's really don't matter. And that you could have done that right here at this step as well. It doesn't matter what I put in for x. If I put a 0 in for both x's, I get 2 equals 2. If I put a 1 in for both x's, I get a 5 equals 5. If I put a 2 in for both x's, I get a, let's see, it'd be 6 plus 2, so 8 equals 8. So x could be anything. So when we have this, going back up to the top, my letter A here is infinitely many solutions. Because we looked at a few different numbers x could be, but it could also be negatives, it could be decimals, it could be really anything, because it just cancels out. So how do we know that we're in this? I'm going to say when you get something equals itself. I didn't really leave enough space there. My original plan was to say a number equals a number. So like I was going to say like this 2 equals 2. But really, whenever you get something like this 3x plus 2 here that equals itself, that would cancel down to a number equals a number. So when you have that, something equals itself, there are infinite solutions. All right, then if we go down to letter B, different type of situation, then we have this here, and let's see what we get. So first step is to get all the variables together in one place. So I have a 4x on both sides, so I'm going to cancel that out. I'm going to subtract 4x here, move it to the other side, and when I do that, they both drop out, kind of like we had before in that last step, but our result is something different. Where before we had this 2 equals 2, you still can see it at the top of the screen, and 2 always equals 2. Now here we get negative 7 equals a positive 8. And that's not true. Negative 7 never equals positive 8. So when we get back here to this original problem that we had, it really doesn't matter what you have in here, because no matter what you put in for x, you're never going to make that be true, because the 4x's will both be identical to each other, and then you still have this negative 7 equals 8. So when we have this situation, we're solidly in letter B, which is, ooh, that's a highlighter, solidly letter B, which is a no solutions. And that's going to happen when you get a number equals a different number, such as this negative 7 equals a positive 8. So whenever you get that, all the variables drop out, your numbers aren't the same, you get something different. And really, to help you see kind of what we actually have in both of these, if I were to take these here and graph these bottom two equations, if I would graph this one here and this one here, what we're going to get is we're going to get a steep line. Later on you'll learn the slope is 4. And one of them is going to be up here, and one of them, if you would graph it, is going to be down here. So they actually end up being parallel lines. And the solution really is going to be what happens where these two things meet. And if you have two parallel lines, they never meet, so it'll never work. No solutions. Where this other one up here, we have the same slope. Slope is both going to be 3 there, but they're also at the same height. So this one here then is going to be something like this is my first line. Now watch real carefully. This is my second line, kind of drawn right on top of it. So that's why we get an infinite number of solutions, because any of those x values could be solutions. That's kind of what we're happening, but we'll get to that in a few different days. So, all right, that's all I got for you. Knock it out of the park, guys.